So in today's video, we are going to be talking about change of variables, which is a form of basically substitution in multivariable calculus. So in single variable calculus, we learned that we can potentially change an integral using u sub in order to simplify a problem. In multivariable, the idea is similar, even though it's not the same. And so what we're going to do today is do an example and learn from there. So our question is asking us to compute the double integral of x plus 3y dx dy, where d is our shaded region, as shown here. And we are given a hint of the map g of uv, which is equal to u minus 2v and v. And below here, I provided two important formulas where when we integrate a double integral of a function and we are using change of variables, what we're going to do is we literally change our variables of x and y to x of uv and y of uv. Basically meaning we change our variables in terms of u and v to simplify our problem, and we have an extra factor of what we call the Jacobian of uv, or Jacobian of g. There's also something called determinant of g, which is the same thing except that we use determinant when it is a linear form, but when it's not, we can use the Jacobian, and it applies to all kinds of things, even if it's linear. So we're just going to do Jacobian of g. So in this problem, we are given the hints, and I have written down that this is represented as x and this is represented as y. So let's write that. We have x equals to u minus 2v and y is equal to v. And so when we do change of variables, that's our first step. We want to identify what x and y is. And then from there, we want to figure out our bounds, because in double integral, we want to have bounds basically, right? So we want to figure out the bounds for u and for v as well. And we can do that by looking at the region here. So we have two equations. We have x plus 2y equals to 10, and we have x plus 2y equals to 6. So what we can do is we can replace these values with u and v. So x is equal to u minus 2v, so we can do u minus 2v plus 2 times y, which is v, equals to 10. And then, let me just put this somewhere here. So we solve for this, and we get u minus 2v plus 2v equals to 10. The 2v cancels out, so we get u equals to 10. And then here we do the same thing, u minus 2v plus 2v equals to 6, and we get u equals to 6. So from here we see that our bounds for u is essentially between 6 and 10. And then now, to figure out the bounds for v, we know that v is the same as y. So if we take a look at this we can just change into v. So in change of variables, sometimes we want to transform our graph into a new plane in terms of u and v. And in this case, we see that y is essentially the same as v. So our bounds of y will be the same as our bounds for v, which in this case is between 3 and 1. So we can do that. So v is between 1 and 3. So that's our bounds, and we can put that into our double integral. So this is step number 2. Step number 3 is plug in the bounds. It's up to you which step to do. Honestly, we could put the bounds in, but actually we should also calculate what our Jacobian is. So actually our third step is to calculate Jacobian, and we do that by using something called like a matrix. And previously we learned what cross product is, so I'm sure this should be somewhat familiar. So if we do Jacobian of g, we want to have the partial derivative of our function x in terms of u. So or with respect to u. So in x, we look at x, and then we want to derive with respect to u. So kind of similar to my previous video on partial derivative, we are treating the other variable v in this case as a constant. So here, our derivative with respect to u is just 1. And then now we do the same thing here, also the same x, but now with respect to v. So our derivative with respect to v would just be -2 because u is a constant and that cancels out, and so our derivative is -2. And then in the bottom here, we have dy by du. And so we look at this and we do with respect to u. And in this case, there's no u, so we know that our derivative is just going to be equal to 0. And then here we have dy by dv, and the derivative with respect to v is just 1. So we compute this, we do 1, right? 1 times 1, so these two multiply by each other, and then these two multiply by each other, and we subtract them. So ultimately we just get a determinant or Jacobian of 1. So now that we know our Jacobian and we know our bounds, we can plug everything in. So our last step is to plug everything in. So we are doing du dv. So our bounds for du is between 6 and 10, and our bounds for dv is between 1 and 3. And we have f of x uv comma y uv. So everything should be with respect to u and v, and we already know that from what we've written here. So if x is equal to u minus 2v, we go back to the problem in the beginning, which was x plus 3y. We just plug x as u minus 2v and y as v. So x plus 3y would be u minus 2v, that's x, plus 3y, which is just 3v. And then we do it with respect to du and dv. And then now we just calculate that. Usually we also have, as you can see in our formula, we have the Jacobian, but we've calculated that it's just 1, so it's already included in. And we just need to compute this double integral. And so to compute it, we can first simplify our problem. So we have u minus 2v plus 3v du dv, which is the same as u minus 2v plus 3v is just plus v. And so from there we can calculate it. So first we can do the inside integral first. So we are integrating with respect to u, which in this case would be u squared over 2 plus vu, because we're treating v as a constant. And so to calculate this inside, we have 10 squared, which is 100 over 2, plus v times 10, 10v, minus 6 squared over 2 plus 6v. So let's simplify this. We have 100 divided by 2, which is 50, plus 10v minus 6v is 4v. And then 36 divided by 2 is just 18. And we further simplify this. We get 50 minus 18, which should be 32 plus 4v. Now we integrate with respect to v. So we get 32v plus v squared over 2. V divided by 2 is just 2. And we plug the bounds in and we get 32 times 3, which should be 96, plus 18 minus 32 plus 2. Minus 2. And all this should equal to 80. And so that's our answer for this problem. This is a simple problem on change of variables, and it is a good introduction. And I hope that you guys learned something new today. So thanks for watching.